Hi, everyone. So normally we would be Zooming today, but my dog got hurt. And so I have to take her to Cornell tomorrow, or well, today's Tuesday. So on Wednesday, I have to take her to Cornell during our class time. So I'm going to make a video because I refuse to let us get behind. The supplement you have is called the Rectangular Coordinate System. So look in the note packets that you picked up, and we're going to work through a section. My math lab will be open, so you can get in there and start playing with it. And then on Friday, we will resume with Zoom. So we'll be together with Zoom on Friday. And then we will get into some of those sections in chapter 5, which I know are probably going to open up on my math lab, but don't worry about it. We're going to get to those on Friday, right? So let's open up. I just have a little document camera so you can see what the section is. So take a pause, find it in your notes, and let's work through this together, right? So this is a little supplement. You'll see it open in my math lab. It's called the Rectangular Coordinate System. And it's probably a review, but it's a really good review to work through some of this. So we're going to take the definition of a plane. And so a plane is really a theoretical concept because it says it's a flat surface that continues without end. So what we talk about, because really nothing goes without end, a plane can't go without end, we talk about portions of planes. So an example of a portion of plane would be this piece of paper, right? The sheet of paper, or my tabletop, or your desktop, right? It's just a nice flat surface, and that is what a plane is. So I'll write this down. So the piece of paper is an example of a plane. Your desk is an example of a plane. The whiteboards at school would be an example of a plane, portion of a plane. All right. So what we're going to do is we're going to take a portion of a plane and we're going to divide it up into 4 regions, right? So I bet you guys remember making like this big plus sign, and then you started labeling your ticks, right? Your tick marks. So what I have here is typically what is called the XY plane, or you'll hear it called the rectangular coordinate system. Okay, the XY plane or the rectangular coordinate system. So it asks us to label the x-axis, the y-axis, and the origin. So the x-axis is this horizontal line that we've drawn that goes from left to right. This is what's called the x-axis. And the one that's vertical that goes up and down, we typically call this the y-axis. Right? And where they cross, goes right in that middle part, is what's called the origin. So where the x-axis and the y-axis cross is called the origin. So the quadrants, the 4 parts that this plane's been divided up into, typically are denoted with Roman numerals. So this quadrant in the upper right-hand corner is called quadrant 1. And then it goes counterclockwise. So 1, 2, this is quadrant 3, and this is quadrant 4. All right, so the origin separates the positive x values from the negative x values. So these are considered input values, or the x value of what's called an ordered pair, which we'll get to. But that origin divides them up from positives to the right and negatives to the left. So in quadrant 1, like if I find myself in quadrant 1, I start at the origin and then I'd have to work my way to the right. So all the values in this quadrant, the x values, would be considered positive. To get to quadrant 1, I'd have to go to the right. And so that's making positive x values. Okay? The origin also splits the y values between negatives and positives. So if you go down, you generate negative y values, and if you go up, you generate positive y values. So if I were to get into quadrant 1, I'd go to the right, which would be a positive x, and I would go up, which means a positive y. So y would be greater than 0 if I'm in quadrant 1. So if I'm in quadrant 2, I have to go to the left, and then I have to go up. So working your way to the left from the origin makes negative x values, or x is less than 0. Okay? So if I go to the left, x is negative, but to get to quadrant 2, I have to go up. And moving up is a positive concept on the xy plane. So y would be positive. Down here in quadrant 3, I'd have to go to the left, which generates negative x values, and then down, which also generates negative y values. So if I'm hanging out in quadrant 3, all my x values would be negative, and all of my y values would be negative. And then if I'm in quadrant 4, I would go to the right. A right movement makes x values positive, and going down makes y negative. Okay? That's something that we have to know. You have to be able to label the quadrants as well. Okay? All right, let's flip. Now, what I have here is a scene from a Battleship game. I don't know if you ever played Battleship, but I played that a lot when I was little with my brother, who used to always cheat. So this is like the figures if you've ever played Battleship, and this is kind of what the board looks like. So you place your ships on your board, and then your opponent tries to guess where your battleships are. So you would tell your opponent, so for example, if I wanted to try to guess where this ship was, you see there's a horizontal label that's a letter and a vertical label that's a number. So this position right here, that could be one of two things. You could say that's A8, or you could say that that is 8A, all right? And we would know exactly what you mean. We would find the A, we would find the 8, and we would see where they intersect. So it says, what would be the coordinates for the ship in the upper left-hand corner? So left-hand corner, this right here, you could either say A1 or 1A, and everyone would know what you're looking for. And then this would be either A2 or 2A, and everyone would know that you're looking at that box right there. Okay? So in Battleship, about the ship on the far right side, so maybe down here. So you could say 10F, you could say 10G, you could say 10H, right? It's where this column and these rows intersect. So with Battleship, it doesn't matter, right? You could label this, let's see, you could say F10 or 10F. It doesn't matter because everyone would know how to find that. But on the XY plane, order does matter because both of the coordinates are numbers. So since both of the coordinates are numbers, we need a game plan. We need a game plan, and we need to be consistent so that everyone can work their way around a set of axes the same. So it says to label a point on the XY plane, the two numbers are called coordinates, and they're used to make up what's called an ordered pair, right? So the first number in the ordered pair is called the x coordinate. And the second number in the ordered pair is called the y coordinate. So an ordered pair is a way that we can orient yourself on the XY plane. All right, so it says what quadrant would each of these point lie, and then if it's on an axis, then tell me what axis. So first of all, let's label the axis. So X goes left to right, and the y-axis goes up and down. So we always start at the origin. Okay, we always start at the origin, and then we either go left or right, we hold our pen, and then we go up or down. So if I start at the origin, it goes X comma Y. So if I go to the left, to the right 2, and this down 5, that's where this point would lie. This says go to the right 2 and then down 5. So we are in, let's label our quadrants. 1, 2, 3, 4. This point would be in quadrant 4. Let's try this one. So this says negative values go to the left. So we're going to go to the left 1 and then hold your pen there and then down 7. So that's where this point would lie. So this point would be in quadrant 3. 10, 6. Okay, both positive. So we're going to go to the right 10 and up 6. So that point would be in quadrant 1. So this says 0, 23. Now 23 is not our point doesn't go, this only goes up to 9. So 0, 23 would be like way up here, right? Maybe somewhere around up there. But regardless, do you see that this says 0? So don't go to the left or to the right and just go up. So we're going to end up being on the y-axis. So this one's going to land us on the y-axis because this says don't go to the left or right. Remember, the first coordinate says left or right. And this one, that should be a comma, this one says go to the left 4, but then don't go up or down. Then stay there. So that would land us on the x-axis. Now let's talk about what the origin is, the ordered pair for the origin. The ordered pair for the origin is 0, 0, because we're not going left or right, and we're not going up or down. So we're staying still. So if we're at the origin, that ordered pair is 0, 0. All right, so I'd like you to pause the video if you wouldn't mind, and then give these problems a try. Okay, so pause the video and see if you can find ordered pairs to match up with those 2, 4, 6 points. Okay, so give it a pause and then come back. All right, I'm hoping you paused. So I'm going to go over it and see how you did. So A looks like it's -2. So to get to A, I would start at the origin. You always go to the left or right first. So I would go to the left 2. So that would be negative. And then up 1. Going up 1 is positive. Right? So you always start at the origin. Now to get to B, I don't go to the left or right. Do you see that? I don't go to the left or right. So this would be 0. And then to get to B, I go down 4. So down, of course, means negative. All right. So for C, you go left or right first. So it looks like I'm going to go to the right 3. And then up 2. Up is positive. For D, I start at the origin. I go to the right 2. And then down 5. For E, it's right there. So I go to the left 4. And then I go down 3, right? To the left 4, down 3. And then for F, where is it? F over here. It looks like I go to the right 5, but I don't go up or down. I stay right on that x-axis, so that'll be 0. All right, let's try a couple more. You ready? So pause the video and go ahead and plot some points. All right, so give it a pause. Plot some points and then come back and we'll see how you did. Okay, so give it a pause and then come back. All right, Here we go. You ready? So this says to the right 2 and then up 4. So that's the point 2, 4. This says to the right, remember, look, do you see, I notice every time my pen starts at the origin. So this says to the right 5 and down 3. You always go left or right first. So this would be 5, -3. This says don't go left or right, but then you go up 2. So there's 0, 2. This says go to the left 4 and then up 1. Okay, how'd you guys do? Oh, I wish we were together. All right. So let's do the next one, see how you did on it. Turning off my phone because I don't want it to ring. All right. So this one says, start at the origin, go to the right 4 and down 1. So that's 4, -1. This says, start at the origin, go to the left 2 and down 3. So -2, -3. This says, go to the left 1 and up 4. Remember, positive means up for the second value. Positive 4 means up. And this says, go to the right 3 because it's positive, and then go up 4. Right? All right, so hopefully that's good with plotting points. So let's get into my math lab questions. So let's go through them and see how you do on it. It says, note that the axis divides the plane into 4 quadrants as shown to the right. If B is a positive number, determine whether the following statement is true or false. All right, 0, B. So this means don't go to the left or right. And then this says if B is positive, you go up 4. So you don't go to the left or right, and then you go up. So I'd imagine that that's what that point's going to look like right in there, right? 0, B. All right, so choose the correct answer below. So this is definitely true, right? It's going to line the y-axis, so we can get rid of this one. We can get rid of that one. It's not false, it's true, so let's get rid of those. So it's true because the x-coordinate of the ordered pair is 0. Yeah, it's true. If the x-coordinate is 0, then you're only going up or down. So it's this one right here. Okay. How about this one? The point -a, b lies in quadrant 3. All right, well, let's see what we got going on here. Let's label. Let's get practice labeling these. There's 1, 2, 3, and 4. Okay. So A is negative, so that means we go to the left, and B is positive, so we go up. So if I start at the origin, I go to the left, and then I go up. I'm hanging out here in quadrant 2. So that's what -a, b would be. So does this lie in quadrant 3? No, it's false. All right, so let's get rid of that one because we know that can't be true. Oop. All right, false, because the ordered pair, -a, b, lies b units to the right of the y-axis. No, it's a units, right, to the left, right? When we started here, we went a units to the left and made it -a. And then we go b units up, b units above the x-axis. So let's see. So this one can't be. That's not true. So we go a units. Do we go a units to the right of the y-axis? Remember, this is the x and this is the y. Oh, we go a units to the left. We're on this side, so this one can't be true. False, because we this point lies A units to the left of the y-axis, and then B units above the x-axis. Does that make sense? That was kind of tricky. That one okay? Right? We go to the left of the y-axis, and then we go above the x-axis. Okay, so that's why it's false. All right, here, try this one. Is the ordered pair -6, 8 plotted above or below the x-axis? All right, let's try it. Here we go. So here's my x, here's my y. So to plot this, I'd start at the origin. The -6 says to go left, and the 8 says to go up. So I'm somewhere in here, right? That's what this would look like. So is it above or below the x-axis? So I'm hoping you're going to say it's above. So we can get rid of any of them that say below the x-axis, because it's definitely above the x-axis. Is below the x? Nope, that can't be true. Let's get rid of you, right? Is there another one that says the point is below the x-axis? Do you see another one? Yeah, this one. Let's get rid of this guy. We're above the x-axis, not below it. All right, so which one is true? The ordered pair, -6, 8, is plotted above the x-axis because in -6, 8, the x value is positive. Is that true? No, the x value is negative, right? It goes x, y. Nope, that's not the reason why. All right, so I'm going to circle this, and then let's read it to make sure that's the right answer. All right, the ordered pair, -6, 8, is plotted above the x-axis because in -6, 8, the y value is positive. Yes, so if the y value is positive, we go up from the x-axis. That one's true. All right, take a pause, plot these points, and find the perimeter of the polygon that you're going to make. So you got to add up the lengths of the sides, right? So give it a plot. Go ahead and plot it. You don't need to pause the video. Go ahead and plot it. Okay. You plot it, I'll plot it. Let's see, so 0, -2. It says don't go to the left or right. Just go down. 2, -2. I wish I wore my glasses. And I don't want to pause this video to go get them. So let's see. So I'm kind of stepping back to look at this. 2, -2. So start at the origin. Go to the right 2 and down 2. Okay. 0, 4. So 0 says don't go to the left or right, but then go up 4. And 2, 4 means go to the right 2 and then up 4. Okay, so did you get this nice, you can almost see it, right? This nice little polygon. It looks like a rectangle. All right, so let's count. Let's see what the lengths of the sides are. So this looks like it's 1, 2 units. 1, 2. So this is 2 units. So this would be 2 units because it's a rectangle. The opposite sides are the same length. And then just count your ticks. We've got 1, 2, 3, 4, 5, 6. So this side would be 6 units. And then this side would also be 6 units. Let's do the perimeter and the area. Ready? So the perimeter, go ahead and do it. So add up the sides. Did you guys get 16? So this will be 16 units in length. It goes 6, 7, 8, 14, 15, 16. Right? We add up the sides for perimeter, and then area is length times width. So 2 units by 6 units. 2 times 6 is 12. Units by units is square units. All right, so that you have a couple of those. You can tell I printed those off of my math lab. So you have a couple of those to play with on my math lab. And then let's play a little bit. Again, these are just some more types of questions off my math lab. Let's just start working through them and see how you do. So it says, tell whether the following statements is sometimes true, always true, or never true. Okay, and then explain your reasoning. So the x coordinate of points in quadrant 4 are negative. So let's draw a picture. Let's get in the habit of labeling our axes and the quadrant number. So the upper right-hand quadrant is 1, and then it goes in a counterclockwise direction, right? The opposite of counterclockwise. So the coordinates of the points in quadrant 4, the x coordinates, so if we're over here in quadrant 4, are the x value is going to be positive or negative? Well, to get over there, I would start at the origin and I would go to the right. So if I go to the right, that's a positive x. The y's would be negative, right? I have to go down. So that would be negative y's. But if I work my way to the right, then it is never true. The x coordinate of points in quadrant 4 are negative. This is never true. Right? To get to quadrant 4, we have to go to the right on the xy plane, and that produces positive x values. To get into quadrant 4, we need to move to the right from the origin. Okay, this is a positive. That produces positive x values. This means x is positive. The x coordinate is positive. Moving to the right is a positive concept. Okay. Tell whether the following statement is sometimes true, always true, or never true. Explain your reasoning. The x coordinate of a point in quadrant 3 has the same sign as the y coordinate in quadrant 2. All right, here we go. So here are my labels, 1, 2, and 3, and 4. This is y, this is x. All right. So the x coordinate of a point in quadrant 2. So if I'm over here in quadrant 2, I had to have gone to the left first. So that means x is negative. Okay. If I'm in, it has, I just did that wrong. So scratch that. They wanted to know the x coordinate of a point in quadrant 3. Okay, so I'm down here. I read that wrong. I told you I should have my glasses on. So if I'm down here in quadrant 3, same thing. The x is negative. Okay, so in either case, if I'm in quadrant 3, the x has a negative value. But the y coordinate in quadrant 2, so if I'm up here in quadrant 2, the y is positive, right? Because I have to go up to get into quadrant 2. So in quadrant 3, the x is negative, so this is never true. Let's explain it. So the x coordinate in quadrant 3 is negative, right? But the y coordinate in quadrant 2 is positive. I'm running out of room. I'll write it right here. I'll sneak it up here. The y coordinate in quadrant 2 is positive. So their signs are not the same. They're actually the opposite. All right, ready? Let's try one more. It says, name the ordered pair that is 4 units right and 2 units down from -3, 2. So if you have graph paper, you could use graph paper to do this. I'm just going to use some of the graph paper that we have on a different page. So I'm just going to sneak over to, here, I'll just flip back and look at this one. So it says, we're looking at the point -3, 2. So -3 up 2 on my graph paper, -3 up 2 would be right here. This is just the graph paper that we use to make our polygon. So there's -3, 2. So they said from that point, we're going 4 units to the right and 2 units down. Okay, you ready? 1, 2, 3, 4 to the right, and 2 units down. Looks like I'm going to be at 1, 0. Let's try it again. 4 units to the right. So 1, 2, 3, 4, and then 2 units down. 1, 2. That's going to put me right there at 1, 0, right? I go to the right one, but I don't go up or down. So that ordered pair is going to be 1, 0. Now, we know fractions. So this one isn't a big deal. Even, it shouldn't be a big deal regardless, because we're really just looking at the sign of the numbers, right? Okay, so -5/2. I don't care what this number is. If it's negative, we've got to go to the left. And this says +10/3. Well, it's positive. So no matter what this number is, I go to up, right? A positive y is up. So that's going to land me in quadrant 2. Okay, ready? Last one. Then we have a little bit of a challenge to look at, and then we're done. So it says, Delaney made a map of her running trail through the woods in a way that each intersection is a point on a coordinate plane. Delaney plans to start at the point 3, 2. All right, so we're going to do this on another piece of graph paper. We'll find one. So this is where she starts, and she's going to move up 5. She moves 5 units to the right, and then down 7. Okay, so flip the paper, take a pause. Flip the paper. She's going to start here. So find the point 3, 2, and then you're going to move 5 units to the right, and then 7 units down. And see where you are. So I'm just going to do it on the very front of my paper. You ready? So she starts at 3, 2. So I'm just going to do it on this one. It's easy. So she starts up here over 3 up 2. So I'm going to do it in red. So this is where Delaney starts. That's her start. And they said she goes 5 to the right. 1, 2, 3, 4, 5. And then 7 down. 1, 2, 3, 4, 5, 6, 7. So she's right here. So what is that point? Looks like it's to the right 8 and down 5. So to the right 8 would be positive 8 and down 5 would be negative 5. So she found herself in quadrant 4, down at the point 8, negative 5. All right. So she found herself in quadrant 4 at 8, negative 5. And it looks like we said quadrant 4. All right. Last little bit. Take a pause. Pause the video. Go ahead. Review perimeter and area. So draw that shape. I gave you the vertices. Draw the shape, and then go ahead and find the area and the perimeter. All right? So take a pause. Draw the shape. Find the area and perimeter. Pause it, and then I'm going to do it now, and then you can see how you did. All right, so 0, 1. Negative 4, up 1. I'm hoping you're checking this. Negative 4, down 1. And 0. Yep, I drew the first one wrong. So get rid of that one. So the first one, 0, up 1. So it should be 0, up 1, and then 0, down 1. So I'm going to cover that one up. Don't look at that one. All right, let me check it again. So we don't go to the left or right, and we go up 1. We go to the left 4 and up 1. We go to the left 4 and down 1. And then we don't go left or right, and we go down 1. Okay, so I'm going to draw my figure. Draw it in red. Okay, so it looks like the length is 1, 2, 3, 4. So it's 4 units. And then the up and down looks like there's 2 units. So this would be 4 units. And then this would also be 2 units. So the perimeter, you add up all the lengths of the sides. So if you add up the lengths of the sides, looks like you're going to get 12 units. And area, remember, is length times width. So we're going to have 8. 4 times 2 is 8. And then square units. Because the units for area, right, are always the square. And the reason why, now look, we have 4 units times 2 units. So we say 4 times 2, we got to multiply the numbers, but we also have to multiply the units. So units times units would be square units, or units squared, however you want to write it. Right, so hopefully you'll do great on the My Math Lab on that question. Right, and then the only other one is a map question. All right, so this is a family plans to take a theme park trip to different places in the US. This is before COVID. And the family is scheduled to leave New York by plane, fly to Washington, right? So here's where New York is, but y'all knew that. They're gonna fly to Washington State, which is up here, stay for 3 days, and then fly to Southern California, so down here, California. And then from California, they want to go to its final destination down in Florida. All right. It says the family leaves for New York to start their trip. What quadrant does New York lie? So let's label our quadrants. Quadrants, remember, you start in the upper right-hand corner, and you go counterclockwise, the opposite of a clock. So where do they start? So it looks like they start in quadrant 1. It says, at what point does the trip, at what point does the trip begin? Use ordered pair notation. So it looks like you can see these tick marks. 1, 2, 3, 4, 5, 6. And this is where I wish I had my glasses on. I'm assuming that's about 1 tick mark. So I'm going to call it 6, 1. Okay. You go over to the right 6 and up 1. All right, it says name a state that lies directly on the negative y-axis. So this is definitely going to test your state. So what I did is I'm going to stop sharing the screen and I'm going to share another screen. So what I did is I found a map of the US. So look at your paper and then look at the map of the US. You can kind of see Texas. So that red state right there, that big red state at the bottom by the Gulf of Mexico, it looks like the y-axis, definitely the negative y-axis cuts through Texas. You see that? Like the little point of Texas is right where the y-axis cuts through. So I'm going to say Texas for mine. But there's a bunch others, right? Looks like, oh, I'm thinking that Oklahoma is on that negative y-axis. Kansas definitely could be on that negative y-axis. Do you see those states that I'm talking about? Okay, they're very lightly outlined, but you should be able to maybe see that Oklahoma's right above Texas that goes through that, and then Kansas. Look at the map on the screen. You should be able to kind of compare that. Okay, state the coordinate of the point where the trip ends. I'm going to leave this map on there because we've got some ordered pairs in Texas that we have to label. State the coordinate of the point where the trip ends. Well, it ends in Florida. So what do you think? If it ends in Florida, I just ran and got my glasses so I can see. Oh, look at that. It doesn't look like it falls right on the tick, but looks like 1, 2, 3, 4, 5 to the right for sure. And that's where my paper isn't photocopied great. Hopefully yours is a little bit better than mine. Let's say 1, 2, 3, 4, definitely 5 to the right. And we can use a fraction if we want. It looks like going down, it's 1, 2, 3, 4. You guys want to say 4.5 maybe? I'm going to say 4.5, but since it's down, I've got to label it negative. Here, I'll stop sharing my screen. But look at Texas pretty closely. Here, so look at Texas again. Okay. Oh. Did you guys, I wonder if I didn't share the screen before. All right. So I don't know where we left off, but I'm not retaping this. So let's go back. Let's see. So we got to, at what point does the trip begin? All right, so now, I don't think I actually shared the screen before, but I'm not retaping this. We'll keep on rolling. So do you see, now that we can see it, you saw me, I left to get my glasses. Let's look at Texas. So do you see Texas is where that little red lip is right there? That's what I was talking about before. You guys must think I'm nuts. So do you see Texas is that red state right there down at the bottom? You guys must think I'm crazy and I share that part of the screen, but that's okay. We're going to keep rolling. All right. And so here I was looking at 5. Do you guys agree that 5, -4 would be where Florida is, 5, -4? So I'm hoping everyone agrees that that quadrant is 4, where Florida is. Look at your map. Look at your page. You see that's down in quadrant 4, where Florida is. And then this is why I wanted to leave this map up. Write 2 different ordered pairs that represent locations in Texas. So let's look at Texas a little bit. So the yellow part, so Texas is that state on that map. It's red here, but now you can kind of see where it's located on the map that I gave you on your paper. So let's get rid of this stop share. Oh, hello. I'm so sorry that I didn't have that map up there. And then let's share the paper again. Okay. So this is Texas right here. Do you see it? This is Texas, this nice big state. So any of these points, like anything in yellow, anything right in here would be Texas. So you can use fractions if you want. You go -1/2, down 1, 2, 3, 4. That would put your baby right here. You can use fractions, right? We can use fractions. So -1/2. So I went to the left and I went down 4 tick marks. And any of these other points, whatever, I'm pretty sure that looks like would be a Texas. So -1 down 3. We'll call that good. Okay, -1 down 3. All right, and the last bit. This one's a little bit tougher, and I usually put these ones as a bonus on tests. I like this page. I think it's very clever. And it deals with fractions, and that's what we just did. So this is perfect. All right, so let's follow the directions. It says construct an x-axis that passes through the points A, B. So do you see where AB is? We are going to make an x-axis that cuts through these. So there's where the x-axis is. And then it says, up at the top, construct a perpendicular y-axis that goes to the point CF. So perpendicular means it makes a right angle. So there's my y-axis. So do you see, we're really just kind of zooming in on quadrant 1. This would be quadrant 1. This would be 2. This little piece would be 3, and this would be 4. So this problem zooms us in on quadrant 1. Okay? So label the origin. Okay, so the origin are where the x and the y intersect. So right here, here's my origin. All right. Now it says the x coordinate of B is 5 2/3. All right. So this point is 5 2/3. And then we don't go up or down because it's on the x-axis, so it'd be comma 0. That is interesting. Well, what is this as an improper fraction? Does everyone agree that this is 17/3? So I bet you there's 17 tick marks. Let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17/3. All right. So that means it takes, remember it's part over whole, 3 tick marks to make 1. Remember the denominator tells you the number of tick marks to make a 1. So 1 tick, 2 ticks, 3 ticks. So this right here is 1. 1, 2, 3. This is 2. Every 3 tick marks, 1, 2, 3. That'll be 3. 1, 2, 3. This is 4. 1, 2, 3. This is 5. 1, 2, 3. This point would be 6. So let's label this. This is going to be 1/3, 2/3, 1. 3/3. If you would rather say 3/3, it's the same thing. So this is 1 1/3. This would be 1 2/3. And this would be 2. So every tick mark is worth a third. So this is 2 1/3. This is 2 2/3. And then if we add another thirds, we're right at 3. So this is 3 1/3. This is 3 2/3. If we add one more third, we're at 4. So this is 4 1/3. This is 4 2/3. If we add one more, we're at 5. So 5 1/3, 5 2/3, which you already knew, and then 6. So it asks us to label the numbers along the x-axis. And then they said 3, the point C is 5 1/3. So up here, we don't go to the left or right, but we go up 5 1/3. So 5 1/3 as an improper fraction is 16/3. So I bet you there's 16 tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So remember, this denominator tells you the number of tick marks to get to 1. So 1, 2, 3. There's 1. 1, 2, 3. There's 2. 1, 2, 3. This is 3. 1, 2, 3. This is 4. 1, 2, 3. This is 5. That would be 1 tick mark, so that's 5 1/3. All right, let's start answering the questions. Okay, I'm going to leave this up. You don't have to tear yours off. I'm going to tear mine off so I can go back and forth, okay? But you don't have to tear yours off. It says, for the following problems, consider the points A through N on the previous page. Identify all of the points that have an x-coordinate of 3 1/3. Okay, so we labeled them. Here's my 3 1/3. This is my x. X goes to the left and right. So the points that have 3 1/3 would be, go to the right, 3 1/3, J, I, H, and D. Those all have an x point that is 3 1/3. Identify all the points that have a y coordinate of 2 2/3. Okay, we didn't label all these, but that's okay. There's 1, 2. So this is 2 1/3. Remember, each tick mark is worth 1/3. This will be 2 2/3. So right here, I'll label it in red. This is 2 2/3. So we've got F, E, H, and K. All right. So these are the points that have a y coordinate of 2 2/3. All right, so which point is 3 1/3 above the x-axis and 2 2/3 to the right of the y-axis? All right. So this means if we're to the right of the y-axis, we go to the right 2 2/3. And if we're above the x-axis, then we had to go up 3 1/3. So they gave it to us backwards. They tried to trick us. So let's go over 2 2/3. There's 2 2/3. And then up to 3 1/3. So let's find 3, and then we'll go up one more tick because each tick is worth a third. So did you guys find yourself at G? So we're going to the right 2 2/3, and we're going up 3 and one more tick. Okay. All right. Which point is located 5 1/3 units from the y-axis? So the y-axis is this way. So if we're going 5 1/3 unit away from it, then we've got to go over here. So 5 1/3. So there's your 5 1/3. Do you see what point that is? It looks like it's the point K. Is 5 1/3 away from the y-axis. Which point is 1 2/3? Which point is located 1 2/3 units along the x-axis? So we're going to go not away from it, but along it. So we're going to go 1 2/3 along the x-axis. So this is the x-axis going left or right. So if we go 1 2/3, that's right here. And it looks like it's the point M. Okay, why don't you take a pause and see if you can label the coordinates for K, I, B, and C. Okay, take a pause. Pause the video and see if you can label the ordered pairs for K, I, B, and C. And then I'm going to do it right now. All right, I'm hoping you paused. So K would be over 5 1/3 to the right. I'll show you the answers in a minute. And then let's see. To find K, it looks like I am at 2 2/3. Up. Both are positive. It looks like I had to go 3 1/3 to the right. And to get to I went 1 1 1/3, 2 1/3. So it would be 1 1/3, 1, I think I said that wrong, 1 2/3. Do you see that? To get to I, you start at 1, then you go 1/3, 2/3. So it's 1 2/3. B, we already know. B, we've already done. It's 5 2/3, comma 0. And C, we've already done. It's up here at 0, 5 1/3. Okay. Hopefully these make sense. I wish we were together so I could look at your faces. But we're just about done. A couple more to go and then we're done. So go ahead, pause it, and see if you can find these points. What points are associated with each of those ordered pairs? All right, pause it and try it, and then come back on, because I'm going to be working on them right now. All right, so 1 2/3, up 1, 2. Remember, each tick mark is worth a third, so that's 1/3, 2/3. So that would be point M. The first one is point M. I hope that's what you got. So the next point, I don't go to the left or right. I just go up 1, 2, and then 1/3, 2/3. So that would be F. For the next one, I just go to the right one, but I don't go up or down. So that puts me at A. And then for this one, I go to the right 2, and then I go all the way up to 5 2/3. So there's 1, 2, 3, 4, 5, 1/3, 2/3. So that looks like that is at the point N. Now this one I thought was tricky. Which point has an equal X coordinate and a Y coordinate? So which point has the same X? I think the answer, let me look, I think that the answer was L. Do you agree? So the units for L are over 5 to the right and then up 5 units. So L has an ordered pair of 5, 5. So I thought that was interesting. I thought that took me a while to do that. All right, last one. Let's go ahead and plot 4 1/3, 4. So if I go over 4, and then I've got to go up 4. So there's 1, 2, 3. So there's 4, and I have to go up. Oh, then I plant it. So I'm going to go over 4 1/3. Didn't go over far enough. So there's 4 1/3, and I got to go up 4. So 1, 2, so you guys doing this with me, 3, and 4, right there. How about 1/3 6? So 1/3 is easy. It's just whoop, right there, just a little hop. And then here, let's go all the way up. Let's find 5. 1, 2, 3. Remember, every 3, we go all the way to the tippy top of this page. That'll be the point 1/3, 6. So 4 2/3, we're going to go 4 2/3 to the right, and then find the 1. So it's right there, up 1. And then 0, so don't go to the left or right, but then go up 1 2/3. So 1, 1/3, 2/3. There's 1 2/3. And they said, what's the distance between E and H? So remember, every tick mark is worth 1/3. So there's 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So the distance between E and H is 8/3. Or if you want to do that on your calculator and you want to put it as a mixed number, you'll have 2 2/3. All right, so that's it. That's all we're doing today. My math lab's open, so give it a try. And then we will Zoom on Friday. Make sure you have these notes done because I'm going to check them on Monday. I'm going to remind you again to watch it. I want to fact check these notes to make sure you watch this video because you don't want to miss these questions on the test and the final. All right, I will see you guys soon. I'll see you Zoom Friday and hopefully face-to-face on Monday. All right, take care.